Welcome to this webinar on how to solve problems with root cause analysis. Throughout this video, you will see a paper and pencil icon on some slides, indicating a workbook activity. When you see this icon on the top left corner, this means I'll be asking you to write something in your workbook or refer to your workbook. If possible, download the workbook from the CCRC before continuing with this course. However, if you're not able to, no worries. Just use any piece of paper and write your thoughts down on that. You can always transfer that to your workbook later. Today's session will give you a good grounding in problem solving, including how to identify and define problems and their symptoms through root cause analysis. By the end of this session, you will be able to identify problems, determine the framework needed to solve them, and be able to apply that framework to find a solution. To give you an idea of what we'll be covering today, I'll run through our agenda with you. First, we're going to discuss problem identification. How do you spot a problem? Secondly, we'll look at problem-solving skills, and then we'll look at the process of root cause analysis and look at a case study. Please notice the workbook icon on the top left. This corresponds to page 2 in your workbook. To get us thinking about problem solving and root cause analysis, we're going to do a brief reflection activity. I want you to identify a situation in which you wish you had applied more problem-solving skills. Maybe you reached a solution, but it didn't solve the actual problem. Or maybe you could never pinpoint what caused the problem. What happened? Write a few thoughts about that situation in your workbook on page 3. Pause the video and resume when you're ready. So now that you've had a chance to reflect a little bit, let's move on to talking about problem solving. You'll be able to take what you learn here today and apply it to your situation and see how you might have handled it better. Hindsight is definitely 20/20, but we can learn from our past problems and apply new knowledge to be able to problem solve better in the future. What is a problem? How does one recognize a problem? What are the types of problems? In this section, we are going to discover two types of problems, type 1 and type 2. I'm going to show you a few pictures where you will need to spot the problem in the photo. For each photo, pause the video and write in your workbook what you think the problem is. Resume the video when you're ready. What do you think the problem is in this picture? Go ahead and pause the video and write your answer on page 4 of your workbook. Resume the video when you're ready. We can see here there is a flat tire. Without even knowing why the tire is flat, we know we ought to replace it with a full tire so we can drive again. Some quick troubleshooting will tell us why the tire is flat. For example, we drove over a nail or we have low tire pressure, and what we can possibly do to avoid getting a flat tire in the future. How about in this picture? What is the problem? Pause the video and write your answer on page 5 of your workbook. Resume the video when you're ready. In this picture, we can see this plant is dead or nearly there. Without even knowing why the plant is dead, we know we must salvage the plant or throw it out and get a new one. With some quick troubleshooting, we can figure out why the plant is dead. For example, it wasn't watered enough or it didn't get enough sun, and what we can possibly do to avoid killing our plant again in the future. Some problems are easy to identify. The pictures I just showed you represent easy to solve problems. Through some basic troubleshooting, we can identify the problem and move forward with the solution. These are type 1 problems. The problem is easy to spot, and you can often solve it on your own or on the go. Now let's move on to type 2 problems. On this slide, you'll see a harder to define problem. Pause the video and write what you think the problem is on page 6 of your workbook. Resume the video when you're ready. This is a picture of what is called a calving glacier. Since the early 1900s, many glaciers around the world have been rapidly melting. Specifically, since the Industrial Revolution, carbon dioxide and other greenhouse gas emissions have raised temperatures even higher in the poles, and as a result, glaciers are rapidly melting, calving off into the sea and retreating on land. So the problem here is the calving glacier, but we really have a much bigger problem, climate change. However, what contributes to the change in climate? Human activities are at the root of this problem. But what human activities are creating this change? What influence does this have on the rest of the globe? And what can be done to correct this problem? This is a much bigger problem than the image lets on. Continuing with our ice theme, this image shows an iceberg, the tip and the much larger submerged portion. This draws to mind the phrase, the tip of the iceberg, meaning there is a small part of something, such as a problem, that is seen or known about, when there's a much larger part that is not seen or known about. These are type 2 problems. They require sit-down, dedicated thinking time for solving. They are more complex problems, and often they're problems that you need a team to solve. This is the type of problem where there's more going on below the surface than we are readily aware of. Knowing the type of problem we are facing can help us plan our problem-solving technique. A type 1 problem requires a different approach than a type 2 problem. And frankly, for a type 1 problem, you probably don't actually need much of a process for getting to a solution. For a type 2 problem, as you're thinking through your problem, it's important to really define it correctly. Albert Einstein once said that given an hour to save the world, he would spend 55 minutes defining the problem and only 5 minutes thinking of a solution. While that may be an exaggeration, it does show the importance of trying to define a problem well before attempting to come up with a solution. There are 2 strategies you can use to describe and define your problem. First, make measurable, observable, clear, and specific statements. Also, identify the discrepancy between a desired state and what is occurring. So in other words, what did you want to have happen and what is actually happening? So let me give you an example of this. Let's say I have trouble paying my bills every month. On the surface, I may define my problem as I don't have enough money. But when I actually think about the situation a bit more, I realize, I've been going to Starbucks every morning before work and every afternoon during my break and buying myself a venti latte. So really, my problem here really isn't that I don't have enough money, but that I have trouble prioritizing and managing my money. That's the actual issue that I need to address. Please note, this slide corresponds to page 8 of your workbook. Let's practice problem identification a little more. On the slide is a picture of a blue screen that has a sad face on it and says, your PC ran into a problem that it couldn't handle. I want you to write in your workbook what you think the problem is and whether it's a type 1 or a type 2 problem. Pause the video and resume when you're ready. This is a type 2 problem. The computer no longer works and is giving a very nonspecific error message. You've probably all gotten this blue screen. Yes, we can just restart our computer and it may work okay for a while, but you know once you start getting this screen, there's a larger problem and usually you have no idea what it is or how to fix it. Time to get IT involved. Please note, this slide corresponds to page 9 of your workbook. Here's a picture of a car going down a road in the dark with one headlight shining. I want you to write in your workbook what you think the problem is and whether it's a type 1 or a type 2 problem. Pause the video and resume when you're ready. This is a type 1 problem. It's a pretty simple problem. A headlight is burned out. There's a fairly small number of possible reasons why this would happen. Typically, a filament or a fuse is burned out. The fix is simple. Replace the bulb or the fuse, and you're good to go. Please note, this slide corresponds to page 11 of your workbook. Now that you have some tools for identifying a problem, what are examples of problem-solving skills? What skills does problem-solving tap into? How do we shore up those skills to be better problem solvers? For example, problem-solving often requires the ability to research. To solve a problem, we must be able to research the causes for the problem. You're not innately born with the ability to be a great researcher. Research skills can be developed so that you can become a better problem solver. Take a moment and write your ideas down for skills that feed into problem solving in your workbook. Pause the video and resume when you are ready. Here are some other skills that tap into problem solving that you can work on. We already talked about research skills. Other skills include attention to detail, active listening, analytical skills, and communication skills, particularly if you're working with a team on solving a problem. Did you list any of those in your workbook? No worries if you didn't. This is not an all-inclusive list. There are many other skills that feed into problem solving. You might be wondering, How can I develop those skills? In order to find ways to grow your problem-solving skills, you have an awesome resource at your disposal, the Career Compass. Within the Career Compass, you have the Career Compass Resource Center, or CCRC, and the Career Compass Catalog, or CCC. These online resources provide NAVFAC civilian employees access to personal and professional growth and development opportunities. You don't need a CAC to access the CCRC, which makes it a great resource to visit on a personal device to watch videos, listen to podcasts, and more. To access the CCC, you do need a CAC. The CCC provides employees with information to help them take ownership of their professional development. It is a searchable compilation of development opportunities across NAVFAC. This is an incredible treasure chest of information holding all sorts of ideas for developing your skills. You can search specifically for problem solving and sort by proficiency level and learning methodology, such as experiential, social, or formal learning. You have these links available to you on page 21 of your workbook. One of the most tried and true ways to solve problems is by using root cause analysis. You've likely heard of root cause analysis, but let's take some time here to define it and thoroughly go through the steps of the process. Root cause analysis is the process of discovering the root causes of problems in order to identify appropriate solutions. When all root causes for a problem are removed, the problem does not recur. Root cause analysis focuses on identifying the main reasons for a problem. Now I'm going to show you a 5-step process you can use to do root cause analysis. You have this slide available in your workbook on page 14 that you'll be able to refer to for future reference. The 5 steps of root cause analysis are: Step 1, problem investigation and identification. Step 2, problem organization and mapping. Step 3, analysis. Step 4, select solutions. And step 5, check solutions. We'll go through each step in a bit more detail next. Step 1, problem investigation and identification. This is the step where you will probably spend the most time. Ask yourself, what is going on? Break the problem down into smaller, manageable pieces and investigate why they are occurring. Ask why, and why again to get to the core of why the problem is happening. Keep asking the why question until the answer does not provide any more useful information. This process is sometimes referred to as the 5 whys, but that's not a set number. A more complex problem may require asking why more than 5 times, or a less complex problem may only require 2 or 3 whys. To make this a little more clear, we will go through an example of this later in the session. Also, you want to collect data to inform this research process. Step 2, problem organization and mapping. Organize the collected information into categories. If possible, map out the organized information, showing cause, into a timeline so that you have a list of events leading up to the occurrence or failure. Step 3, analysis. So now that you've collected your data, you're going to analyze the information you've organized and mapped out in order to really figure out the root cause. To do that, look for patterns, interruptions, timing, and causational factors. An example of this is barrier analysis. Look at the sequence of events to find where physical or organizational barriers may be influencing the problem. What are the barriers? Another example of this would be change analysis. With change analysis, you would look at what changed in this problem compared to previous sequences. Step 4, select solutions. Now that you've determined what the root cause or causes of your problem are, you can more easily determine what corrective actions should be taken. Think through possible solutions and choose the most suitable one. Remember, there are many ways to solve a problem. It's not always going to be black or white, so select the possible solutions and then from those, pick the one that you think will be the best suited. However, it is best practice only to choose one solution at a time to fix the problem. Step 5, check solutions. Use the previously established metrics to assess if the solution or corrective action that you put into place has made a difference and solved the problem. Determine whether the problem has actually been fixed. If the problem isn't solved, try another solution. This is why you should only change one solution at a time. If you change multiple things at once to solve a problem, you run the risk of not knowing which particular fix solved that problem. Now that you're familiar with the steps of root cause analysis, let's look at a real-world case study where root cause analysis was used. You can follow along in your workbook if you'd like, beginning on page 16. The $360 million combat ship, the USS Milwaukee, was commissioned on November 21, 2015 in Milwaukee and left the Canadian port of Halifax bound for Florida in early December of 2015. The USS Milwaukee broke down and completely lost power on its inaugural run. The ship had to be towed back to port, bringing up major concerns about the reliability of the ship and delaying the commissioning of further ships until the root cause of the problem could be found. The late Senator John McCain at the time made the following statement. Reporting of a complete loss of propulsion on USS Milwaukee is deeply alarming, particularly given this ship was commissioned just 20 days ago. U.S. Navy ships are built with redundant systems to enable continued operation in the event of an engineering casualty, which makes this incident very concerning. I expect the Navy to conduct a thorough investigation into the root causes of this failure, hold individuals accountable as appropriate, and keep the Senate Armed Services Committee informed. For obvious reasons, this scenario was very problematic for the Navy. Besides causing embarrassment, this caused a cascade of issues, including impacting the schedule and production goals of the ship, as well as having a large financial implication. To get to the root cause of this, the Navy and its prime contractor, Lockheed Martin, set up a review board to investigate. This is obviously a very complex problem, one which we don't have all the details for, and we can't solve something here today in a few minutes that took the Navy and Lockheed Martin months to figure out. But just looking at some of the details of the situation that are now available, we can get started with recreating the root cause analysis that was conducted. I'm going to read you a few facts of the case. You have these and additional details in your workbook on page 17. During a full power run, the gas engines shut down. An alarm triggered, which caused the USS Milwaukee to automatically make an emergency stop. Metal filings were found and removed from the lube oil filter. The ship restarted its journey. 4 days after the emergency stop, the ship lost propulsion and was unable to proceed on its own power. Metal filings were discovered throughout the gas and diesel engine systems. As a reminder, the first step of root cause analysis is problem investigation and identification. So first, let's go ahead and define the problem. Pause this video and write in your workbook what you think the problem is and whether you think it was a type 1 or a type 2 problem. Remember, type 1 is a simple problem, type 2 is a complex problem. Resume the video when you're ready. This is a type 2 problem. It took months and many people to perform this investigation. The problem was that the ship completely lost propulsion. A very thorough investigation was carried out, including a root cause analysis. With the details we have, let's go through the asking why exercise that you learned about earlier to get to the root cause. If you'd like, you can pause your video after each question and write what you think is the answer in your workbook on page 18. Or if you prefer, you can just follow along here and I'll tell you the answers that were determined in the actual investigation. You can refer to the details of the situation on page 16 of your workbook. The first question directly addresses the problem and is, why did the ship lose propulsion? And here we want to come up with the most basic answer. It will take several whys to get to the actual root cause. It's like peeling off the layers of an onion. And the answer is because the alarm went off and shut down both propulsion engines. The next question is, why did the alarm go off? The answer here was because there were metal filings in the engine system. So when those were detected, the alarm went off and caused the ship to stop. Then the next question is, why were there metal filings in the engine systems, which is not something that should ever happen? The answer is because the clutch was literally ground up in pieces, and in the process, the filings went into the engines. The question then becomes, why did the clutch become ground up? The answer is because the clutch did not disengage in the emergency stop as it should have. And now, moving on to our last question. The next question is, why did the clutch not disengage when it should have? And the answer here is going to give us the root cause. So drum roll here. And the answer is because there was a timing issue with the gearing system. The software did not tell the system to declutch properly. So right here we have the root cause of our problem, a timing issue with the software. Let's go through a summary of the steps of the root cause analysis that was done in this case to arrive at the root cause and the appropriate solution. Step 1 was problem investigation and identification. The problem was that the ship lost propulsion and had to be towed back to port. In steps 2 and 3, problem organization and mapping and analysis, we went through the 5 whys to arrive at a root cause, which was a timing issue with the software. Step 4 was selecting a solution. In this case, the solution that was determined was a big relief for the Navy. It was a relatively quick fix and quite a bit cheaper than what had been feared. It was a tweak of the programming of the software. In step 5, the solution of tweaking the software had to be tested. This was done by performing more extensive emergency stop testing on existing ships and also by doing more thorough testing of new ships before they were commissioned. The problem here occurred in 2015 and has not recurred since the solution of the tweaking of the software was implemented. Therefore, it's safe to say that root cause analysis resulted in the correct solution being put into place to fix the problem. In summary, today we have covered problem identification. How do you spot a problem, and is it type 1 or type 2? We looked at problem solving skills and how you can develop those further. And then finally, we looked at the 5 steps of root cause analysis. Now I have a question for you, and it's not something you need to have an answer for right this minute, but it's something that I want you to think about over the next few days. Ask yourself the following questions. How can I put what I learned today into action? Is there a specific problem I'm dealing with now that I may be successfully able to solve using root cause analysis? And if so, what will my first step be? There is space in your workbook on page 19 if you'd like to write down any of those reflections there. To receive credit for participating in this course, email the address below with the listed subject line, course name, and completion code. Make sure to include all the information on the screen. Thank you so much for participating today. Please email the TFD account listed on the screen and in your workbook with any additional questions or comments, or contact your local civilian training advocate or BD17.